Hi everyone, so in the last video, in this video we want to talk more about IP addresses. So this is where we stopped the last time. I kind of talked about IP addresses, and I kind of differentiated them from MAC addresses. Now, last video I was trying to explain something, but I didn't quite make it clear, especially when it comes to MAC address versus IP address. Okay, so the first thing I want to say is that there are advantages of the IP address over MAC address. Okay, advantages of IP address over MAC. Okay, so why is one better than the other? Okay, especially for large scale things. Now, IP address you can see from the last video that as long as you have, let's say, a number in front, let's say 102, you can narrow down the you can excuse me, you can narrow down the places you have to search. Okay, it allows you it's systematically arranged so that you don't have to query so many networks. For example, if the IP address contains 102 or 100, I won't have to query all the IP addresses in Nigeria because none of them actually have the IP address of 100. Okay, whereas for MAC address, even though each card, wireless card or Ethernet card, will have a different MAC address, well, there's no way of really telling that these two MAC addresses are on the same computer, right? So you can take a look. It just looks like a random string of numbers. Okay, and is there some kind of common number to say that here this MAC address and this MAC address is the same? Okay, it belongs to the same computer. Answer is no. So it's nothing really much that we can do about it here. However, if you look at the IP address, at least in this local network 192.168.7, then you have this number. Okay, and this number will change every time you log on to the internet. You can sort of guess that as long as you have these few numbers being the same, you can sort of guess that they are connected to the same network to an extent. Okay, so as long as you have in the grander scheme of things, you have your proper IP address, you will be able to and you want to send your data packet somewhere, and you have your IP address. Well, the IP address inherently helps you to narrow down your search. Okay, so this is very important. Okay, IP addresses by design help you narrow down the network, the search, so to speak. So by design, they are there to help you to narrow down the search. So maybe 102.1 let's see, 111, 128 and 9. I don't know. I'm just randomly giving some random strings of numbers. Okay, so that's what I want to emphasize here. IP address does have its advantage over MAC addresses. MAC addresses are unique. It helps you to identify which computer is which computer, or which wireless card is which wireless card across the network. Whereas for IP address, it will tell you, okay, within this so-called this computer is hooked up to this network at this spot. So it will help you to search things way easier. Okay, so that's the advantage of having IP addresses. So now let's take a look at something else. So we want to demystify some things about IP addresses. For example, the format of IP addresses. Okay, IP address format. Okay, if you take a look at this IP address here, you will see a string of numbers, each separated by a dot. So and actually, well, you can also look for the IP address of Google. IP address of google.com. Okay, or rather, okay, find my domain to IP address converter. Yeah, so if you search this website google.com, convert the domain to IP, it will be this IP address. If you copy and paste this IP address here, it will bring you to the Google search page. Okay, so this is the IP address. Okay, yeah, so this seems to be the stable IP address. Well, it's not exactly stable, it looks like. You see 142.250.191.228. 142.2, yeah, it is stable. Google.com has this IP address, and its location is of course the United States. So you notice this IP address has a few things you should take note. This is a typical IP address of Google. IP address of google.com. Okay, so this is how the IP address works. Okay, so you have a string of four numbers here. How are these numbers decided on? Okay, so the format is actually quite simple. There are actually there are four numbers: 1, 2, 3, and 4. There are four numbers here. Okay, four numbers. Okay, four numbers here. How are these numbers decided? They're decided by this thing called octet. What's an octet? An octet is actually 8-bit binary number, or, well, 1 byte. 1 byte of binary number. 1 byte equals to 8-bit. Okay, so remember, I think last video we actually talked a little bit about binary numbers. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and in each of these 8 spaces, you can fill it with either a 1 or 0. Okay, and this is 1 octet. Okay, 1 octet. Okay, so what is the maximum number of, what is the highest number you can get with 8 spaces or 1 byte? Okay, and this is a 8-bit. So 8-bit. How many numbers can we fit? So the number is well, since it's binary, each space can either be a 1 or 0. So there are 2 possibilities. And then you power that to the 8, you have 256 numbers. So you, in each of these octets, you have 0 to 255. These are the numbers you can represent inside an 8-bit octet. So you can go from 0, because 0 is the first number, and then you go all the way up to 255. So you notice that every number here will always be less than 255. 142.250.191.228, and you'll see this IP address here, every number is also less than 255. Okay, so now that we have talked about the format of IP addresses, let's also talk about what information they carry. Now, I said before in the last video, they will have information about which network to, what is the address of the network. Now, that's only one part of the IP address. The other part is that the IP address is also supposed to contain information of which computer on the network you're talking about. So let's say, your IP address, which maybe, let's do this. Let's take the Google's IP address for example, 142.250.191.228. 142.250.191.228. Okay, if you type this in your web browser, you'll be directly headed to google.com. Right. Okay, so what information is contained within these numbers? Okay, information contained, it will be 1, network name or network address, then 2, host address. What is the host address? The host address, network. Okay, network we have already covered before. What network address is? This is the network of computers. Host address is which computer within the network. Okay, which computer or device within the network. This is put it simply. Okay, the first part tells you which network. The second part tells you which computer within this network. Okay, so that is what IP addresses are there to tell you. And how do they tell you this? Okay, so I have to really credit this computer networking complete course. They detail it very well. There are 3 main classes. Well, here there are 5 classes of IP address that you got to know, but most important is the first 3. So there are class A, class B, and class C. Now class A IP address quite easy-ish to understand. So let's see. Okay, class A IP address will use the first 3 number. Okay, class A address will use the first 3 numbers to ask which network. Okay, class A. Okay, first octet. First octet denotes network. Okay, let me put on the next one. Okay, class A, first octet denotes network, remaining 3 denotes host. Okay, so the first octet will contain the network, and you can see straight away here, from 1 to 126, this will be the network address. Okay, network address or network number. So usually starts with 1 to 126. Okay, that is class A. Okay, let's move on to class B. Class B, first and second octet denote network address, remaining 2 octets denote host. So how many possibilities do we have here? Okay, according to this, we have about 65,000 hosts on each of the 16,000 networks. Okay, 65,000 hosts on each of these 60,000 networks. It'll be 128.101 to 191.255.255.254. Okay, so anytime you see an IP address beginning with 128 to 191, that will be a class B IP address. Okay, so for example, Google IP address will fall under, it looks like class B. So take a look at Google 142.250. Okay, this is Google's address 142.250. At least for today, 191.228. Okay, 142.250. This denotes the network. 191.228 denotes the host. Okay, class C is the one you're probably more familiar with because that's the one you use to configure your router. Yeah. That's the one you'll see when you configure your router. Right? It's getting late. Yeah, 192.0.0.1 to 223. Okay, so anytime you see 192 to 223. Okay, 192 to 223, class C. Okay, first 3 octets denote network, last octet denote host. Okay, so this is class C IP address. So 192.168.1.1. This is usually a typical router address. So the first 3 numbers, okay, 192, or first 3 octets rather, first 3 octets which are here, this will be host info, network info, and the last octet here denotes host. Okay, the last thing here denotes host. So if you take a look at this one will be a classic example of a class 3 IP or class C IP address. Okay, so at least now you know how to sort of decipher some of these numbers, and at least have some meaning as to what these numbers actually mean. Okay, so these are IP address and classes. Okay, so if you look at this IP config or IPA in Linux, and you type IP config in Windows, you'll notice two different IP addresses here. 192.168.7.139 239 here. That's one IP address. Okay. Then the next IP address is this iNet. Okay, this IP address falls under iNet, and it is the standard IP address we are more familiar with. Then you see this thing called iNet 6. Okay, and it says FEAT EDA 9 7 EBF F60A 449D9. What is this? Okay, so this is called IP version 6. IP version 6. Okay, IP version 6 is a 128-bit IP address. This is a more new version of an IP address, because IP address there are many different versions. So IP version 6 is a so-called later version of an IP address. So again, you can see this IPv6 addresses are represented as 8 groups of 4 hexadecimal digits each. Okay, so you can take a look at this. This is a hexadecimal kind of a thing. Okay, and of course full representation may be shortened. For example, 2001 blah 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 000000000 blah 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 can become represented as this. Where are the zeros? They are hidden between the two semicolons. So we won't see the full address here. If you take a look at this iNet 6 address, so FEAT, then you have a colon. Okay, what this means is that all the extra zeros are sandwiched in between these two colons, and then this is the rest of the IP version 6 address. Okay, so what is the use of IP version 6 address? Okay, where is this? Yeah, what's the difference? Okay, the number of possible IP addresses is about 4.3 billion. Okay, which is a lot, but knowing how many computers we have today and devices, we cannot fit that many computers into so little IP addresses in terms of quantity. So it says 1980s, this is on computerHope.com. This was sufficient to address every network device, but will probably run out very fast. So technologies like NAT, I'm not going to go through that. I'm not really sure what that is anyway, but I've seen this before somewhere. It has delayed the problem by allowing many devices to use a single IP address. But in the modern internet, we need a lot more space. So the major advantage of IP version 6 is that it uses 128 bits of data. In short, we can have 2 to the power of 128 unique addresses. So this is way more than what we need. Okay, this is huge. Okay, you don't really need let's see. Okay, so what I'm saying is that they're basically you'll never run out of IPv6 addresses, so you can just keep indexing them, yeah, you'll probably never run out. However, most of the internet now we are still pretty heavily dependent on IP version 4. I don't know when people will start porting over to IP version 6. Okay, but yeah, if you want to test your IP version 6, you can go to testipversion6.com, and then it will run to kind of check where your IP version 6 is, and this is what you can do. Okay, it says my IP version 4 is this address on the public internet. Okay, so yeah, in my case, I don't have an IP version 6 address on the internet. I guess I only have it locally, but I don't have it. Okay, so this is where you can test your IP version 6 address thing. And yeah, hopefully that demystifies why there are two different versions of IP address which you see here. One is the old format, which is version 4. One is the newer format, which will help to solve, having too many IP addresses squeezed within the internet, So that is what IP version 6 is here for, just to accommodate more space. Alright, next question to ask is that who decides where to give this IP address? Okay, who decides which IP address you ought to have? Okay, the answer is usually there will be a server online, or a server that's not on your computer, using this thing called Dynamic Host Configuration Protocol, DHCP for short. And what it says is that it will help you to assign an IP address, a different IP address every time you connect to the internet. So your IP address will not be the same all the time. Okay, so like I said, the IP address you see here, it will not be the IP address that I will have when I restart the computer, simply because the router at home is going to assign my IP address dynamically using this DHCP protocol. Okay, so it will automatically assign IP address and other communication parameters connected to this network. Okay, so who's going to execute this protocol? Well, DHCP is usually it's a piece of it's a task. It's a task you use to design the IP address. So it's like a process you have on your computer. And who does the work? It will usually be this thing called a DHCP server. And this DHCP server can be done by a router or done by a switch. Okay, we discussed switches before. Routers are like what you have at home. So every time you connect to your router, the router will act as a DHCP server, and it will assign you a dynamic IP address, okay, based on what you have, okay, based on your local network. So usually router IP addresses are class C. So usually these first three numbers don't really, that's the whole thing. First three numbers don't really change so much. But the last number, if it's a class C IP address, it will change every time you connect to the internet. So if you disconnect it and you connect it back, it will change. So I'm not going to demonstrate that for you, but I'm just going to tell you that happens. Okay, so DHCP servers are they can be done either by switches. Okay, it can be done by switches, or they can be done by routers. Okay, we have not covered really what routers are yet. They are more complicated, or they do more things than switches, but I won't touch them yet. So this is a DHCP on a very high level. Just let you know what these things are for. They talk about where who gets what IP address. Okay, so yeah. So what's the deal with IP address, and how does it relate to MAC addresses? Okay, so there are many. I guess there's more than one. Basically the way I learned from the video is this thing called address resolution protocol. So address resolution protocol will map the IP address to the MAC address. Okay, so the analogy I like to use is again the one of a car. Okay, remember let's say this is a car. Okay, this is a car, and then I'll just copy and paste this car many times. Oops. Paste here. Okay, and then the car was supposed to be parked into a parking lot, right? So this is parking lot. I don't know how to draw parking lots properly, but let's say there's a parking lot here, and then you're supposed to park, okay, in the parking lot. Okay, and I'll paste it again. And this parking lot A, maybe it will have, well, the analogy I like to use, the host here. Okay, let me change. Host here will have a MAC address. Okay, MAC address 1, MAC address 2, MAC address 3, right? So this is MAC address 1, 2, and 3, and then this is the IP address. Maybe it's 192.168.1.4. This will be 192.168.1.5. Okay, 192.168.1.6. Okay, so what usually happens is that when you connect to the internet or you connect to the router, okay, let me I don't know how to crop tool. Okay, maybe this will do. Okay, never mind. I will improvise. I'm not sure how to use this on GIMP, but anyway, the crop tool. Okay, there you go. Yeah. So who gets to decide? Okay, so your DHCP. This DHCP is like a parking warden of sorts. It will tell this car and MAC address 1. Okay, you park in this parking lot. First come, first serve, right? So, and then if this car is in this parking lot, this MAC address will be mapped to this IP address. Yeah, the DHCP will assign this IP address to this MAC address, and yeah, so the DHCP will assign this IP address to this MAC address. Okay, so the MAC address, this car will be parked in this parking lot. All right, and then, so to speak, it will be fixed to this IP address. Now, let's say I want to. Okay, so again, maybe DHCP will assign MAC address 1 to this IP address. It will assign MAC address 2 to this IP address, and it will assign MAC address 3. So these are 3 different PCs to this IP address 192.168.1.4. So you have this scenario where you have this MAC address 1 at 192.168.1.5, MAC address 2 192.168.1.6, MAC address 3 at 192.168.1.4. This is IP version 4. All right, and the only thing is that, okay, let's say this computer and MAC address 2 wants to talk to this computer and MAC address 1. Okay, so MAC address 2, the computer and MAC address 2 will know its own MAC address. It will know its own IP address. It will know the IP address of this 192.168.1.5 because that's what I want to send the message to. Okay, but remember, if you want to send it, you need a few pieces of data, right? And remember last time I was talking about Ethernet frame. Yeah, the Ethernet frame. Okay, the Ethernet frame will actually will contain the sender and receiver MAC address. Sender plus receiver MAC address. Okay, so this is what the Ethernet frame is supposed to have. Okay, it will have no data about the IP addresses. Where will the IP addresses be stored? IP addresses will be stored within the data section of the Ethernet frame. So if you have this data over here, okay, the first portion of the data will be where your IP addresses are. Sender plus receiver IP address. Sender plus receiver IP address. So to when you have networks and not just MAC addresses, now you have IP addresses, you need to make sure that you okay, the MAC address, let's say this computer wants to send to this computer. Okay, so this computer 192.168.1.6, it will know its own IP address, it will know its own MAC address, it will know the IP address of the computer that I want to send to, but I don't know the MAC address, and I need the MAC address to finish up this Ethernet frame, because I need to have both sets of addresses. Okay, I need to have both sets of addresses, both the MAC address and the IP address, to send the data properly. Okay, so over like a home network, this is what will happen. You will need to you will need to have both sets of addresses, and one thing, the piece of information that may be missing is this receiver MAC address. Okay, so to complete this Ethernet frame, you will need to get the receiver MAC address. So how this is done? How do you receive the MAC address associated with each IP address? Okay, let me type down how to get MAC address associated with each IP address. And this is the question, and the answer here is this thing called address resolution protocol. Okay, answer, address resolution protocol. It's just a fancy name, a fancy way of saying, okay, let me broadcast a message. I haven't talked about broadcast yet. Broadcast basically is to send a signal to everyone. Okay, so what this car or this computer at MAC address 2 will ask is that, hey, let me send a message to all IP addresses, or all MAC addresses for that matter. Okay, let me send a signal to all cars at this IP address here and this IP address here. Okay, please tell me what your MAC address is. Okay, and address resolution protocol, in layman terms, is please tell me MAC address blocks. Yeah. Tell me MAC address blocks. So this is what address resolution protocol is. So what this computer will do is to send a request for these MAC addresses, and in response, all the other computers will send in the MAC addresses located matched within their IP address. So now this computer here will update, okay, 192.168.1.5 will be associated with MAC address 1, 192.168.1.4 will be associated with MAC address 3. So it's a question and answer. What IP address, can you tell me your MAC address, please? Of course, again, I tell you, when you restart the computer, DHCP will tell the cars to park at different places, and then you'll have to ask the question again. What is your MAC address, please? And this is what address resolution protocol deals with. Okay, so once you have this address resolution protocol, you will be able to have not only both IP addresses, but you will also have both the sender and receiver MAC address to complete your Ethernet frame. Okay, so now you have so-called two sets of addresses to deal with. One is the sender and receiver MAC address, which is needed at the receiving end and the sending end, of course. But to sort this layer, okay, this layer is called the network layer. This is called the network layer. It helps to speed up communication. Okay, this is the main purpose. This set of addresses is here for the purpose of speeding up communication. Okay, I'll just say speed up comms. Yeah, speed up communication. Whereas this one is here it's more of an absolute address. And this layer is called the data link layer. Okay, this is called the data link layer. Okay, so each layer has its own set of sender and receiver addresses. So you have a data link layer, and then you have the network layer. So I've explained what these are for, why we do things the way they are, what is address resolution protocol, and what is DHCP. So I think that's about it for this video. I've talked enough. Thanks for watching. I'll see you again.